In this video, we are going to see how to vary the deck length for a steel composite cross section. Firstly, we are going to use axis-based modeling method. In that, we have created one axis and we are having variables under that axis. We double click on variables. Let's create variables. I'm going to create one variable for G1 girder and another one for G3. Okay, I'm going to vary my length from the center to the edge of the deck, so that will be based on the stations. I will get the calculations on the stations itself. So S is my first station, then I'm going ahead with the splice locations S1, S2, S3, S4. You can at the same time see where exactly I am. Okay, and yeah, you can see this is S4, ES, S1, S2, S3, S4, and lastly E. Okay, I don't want to use the rest of the stations or positions, so I'm just going to select and delete them. The transition for my case is spline, so I can select all of these and change the transition to spline type. Now here I'm going to provide the values. So what values we need to take, let's see that. I'll click OK right now, and the information is saved so far. I just need to go ahead and check the distances. So the distances would be, make a DI, and I want to find out what is from here to the perpendicular. So that is distance of 0.5079. Okay, so I'm gonna note that information down. Okay, similarly, I'll go to the next station. That's my S1 location here. Again, I'll go ahead with the DI and look for perpendicular, and the distance is 1.6876. So in millimeters it will be 1687.6. Then I'll go ahead to the next station and I'll do DI again, and I'll go ahead for a perpendicular, and that perpendicular is at a distance of 2047.5. You can see that from here. This is the distance that I'm looking at. Okay, now the next station, and so on. Perpendicular, yeah, that is 1464.9. If you know these points already, you can directly provide the information in the variables 821.1, and lastly we have 0.301, that is 301. Alright, now I will go to the variables, and here I will input the values 507.9, then 1687.6, then 2047.5, and I have 1464.9, and then 821.1, and finally 301. Okay, so this is the information I have got, and I'll go ahead, click OK. I will be pausing my video recording right now, and I'll do the same thing for the G3 girder by finding out the distances from here to here at each of these stations, and then we will go to the next step. Okay, so for G3 I have got these values and I'll click OK. Alright, now let's incorporate these variables in the cross section. How to do that? You just have to double click on the cross section. I'm starting with G1 mid, and I have already created thin walled cross section for my steel composite, and now I'm going to start with Cartesian reference on the left side. Since the variation is on the left side of my G1 girder, I'll start the at the point where the change should take place. So this is the point which should vary with respect to the center. Okay, so you can select the CFL, that is once for the horizontal distance, and now I'm going to click at the same position for vertical distance. So click again and I'll select CFL. Okay, so I have over here 0 vertical distance, of course, and horizontal distance is 1500. I will click on this lock button and I'll click unlock and keep the negative sign. Since it is towards the left side, it will be negative Y, and put hash G1. Now before I do this, I have to also make sure that I go to the cross section properties and go to the variables and import my G1. Okay, so you just have to click on import, select G1, say add to section, and that's your G1 over here. You need to do this before you provide any information over here. So I have I've got my Cartesian reference. I'll click on this unlock button and put up minus hash G1. Okay, I'll click OK and I have minus hash G1. That is it I have to do. I'll click on calculate, close and save. Alright, do the same thing for G3 mid, and for G3 mid it will be on the right side, except instead of the left side. Do the same thing for G1 end and G3 end. So you can see how I've done it already. Right, so this is on the left side, right side now, and I've used hash G3. Notice that it's a positive point now. Okay, so that is for G3 mid. Then I've done the same thing for G1 end. Click, you will get to know what is the information for that Cartesian coordinate, and G3 end. Okay, so that is it. Let me save this and I'll share this file with you. All you have to do now is export this to see if the variables have worked or not properly the way we want. And when we come back to SSD, we can now see how nicely the curvature has taken place. I'm going to open the groups in the viewer, and I will turn off the quads view. Okay. There are no quads now, only 9 elements, as you can see. So very nicely we have curvature in the right flange for our G3 girder and left flange for G1 girder. That's it.